Okay, so this is notes 21, the square root property and completing the square. So now we're going back and talking a little bit more about quadratic equations. Okay, so we mentioned that a little bit in the beginning, and now we're going to go on and learn how to solve them by completing the square. And when we're completing the square, we're going to have to use our perfect square method that we learned in the prior notes about factoring. So the first concept we're going to look at is how to solve quadratic equations by using the square root property. So it says for any real number k, if x squared equals k, then x is equal to the positive square root of k or the negative square root of k. So this is where we were talking about it a little bit yesterday, how if we have something squared and to undo it we take the square root, we're going to get not only the positive answer but also the negative answer. Okay. And we write that solution like plus or minus the square root of k. And of course k is a number, and we're going to be solving the next three examples, and you'll see where those numbers are coming from. Okay. So in this first example here, we want to get p by itself. In order to do that, we need to get rid of the 4. How are we going to get rid of it? Dividing by 4. Oops. Here, dividing by 4. So we have p squared is equal to 9/4. We're just going to leave it as a fraction because we can't simplify 9 divided by 4. And then we want to get p by itself, so in order to get rid of the square, what would be the opposite? The square root. Okay. So when we take the square root of the other side, what happens is the square root and the square cancel. And so we are just left with p is equal to, and we always include our plus and minus. So p is equal to plus or minus the square root of 9/4, which, yes, we could simplify this and say this is the same as plus or minus the square root of 9 over the square root of 4, which is equal to plus or minus 3/2. So that would be our answer. Sometimes we may not be able to simplify it all the way, and we will end up with a radical in our answer, and that's okay.
Radical is what again?
In this case, it's the square root.
Okay.
But it could be like the cube root, the fourth root, any of those nth roots.
All right.
So it's plus or minus because if we were to plug this back in and check, and we don't have to do that for this, but if we were to plug it back in to check, this is going to be p squared when we plug this in. So we have to think of both the positive and the negative term, because what happens when you square a negative number? It turns positive. So we don't know if the original p-value was a positive value or a negative value. So we have to assume that these are two possible answers. Okay. So same idea here. We want to get the x by itself. So what would be our first step? Good, subtract the 75. So I have 3x squared is equal to negative 75. Now what?
Divide by 3.
Divide by 3. So I have x squared is equal to negative 25. Okay. And then we would take the square root of both sides to cancel out that square. But when we take the square root of the other side, we're doing the square root of a negative number. So remember before we would say, well, we can't do that, that's no solution. But this time we can convert it to imaginary, which means x is going to equal plus or minus what? 5i. Right? The I comes out, or sorry, the negative comes out and that becomes I. Okay. Then we just have the square root of 25, which is 5, and our answer is always going to be one positive, one negative, so plus or minus 5i. And then you can, if you need to refresh, this is the same as saying I times the square root of 25, and that's how we got 5i. Okay. Okay, and this one we have to get w by itself. But notice that w plus 3 are both being squared. So that means first we have to get rid of that square by doing what to both sides? You could. That's the longer way. Yes, you could. Good. Do the square root of both sides, right, to get rid of that square. Right, because that square root is going to get rid of this square. If you were to write it twice, w plus 3 times w plus 3 in FOIL, you would end up factoring and end up getting a same answer. This is just a shorter way to do it. So then I have w plus 3 is equal to the square root of 20. Or I'm actually missing something in front of that square root of 20. What am I missing? Plus or minus. It's always plus or minus. Let me try to, there we go, get some space there. Plus or minus square root of 20. And since the square root of 20 is not something that we can just perfectly take the square root of, what we should try to do before we subtract over the 3 is see if we can simplify this. Take 5 out, so it'd be 2 and 10, and then 2 and 5. So we're actually taking the 2 out. And so this is w plus 3 is equal to plus or minus 2 square roots of 5, because we had a group of 2 there that we could take out. And then we would just subtract the 3. So we have w is equal to plus or minus 2 square roots of 5 minus 3. Okay, this would be our answer. Okay, if it asks you to simplify, like put it in decimal form, that's when you would go to your calculator and you would type in the square root of 5, whatever that number is, times 2, and you would get a decimal answer for this. Then you're going to treat this as one positive, one negative, and subtract each of them from 3. So just so I have it on the notes, I'm going to show you what that would simplify to. So let me open up my calculator. So if I did the square root of 5, okay, this would be equal to, yes, plus or minus 2 times 2.24 minus 3. So I'm just going to round to 2 decimal places. Okay, I don't need to write all those decimals. And so then if I multiply that by 2, I get this is equal to plus or minus 2.24, yes, 4.48 minus 3. And so this is telling me I'm going to get 2 possible answers here, okay? I'm going to get one where 4.48 is positive. So that means I'm going to have 4.48 minus 3. And then I'm going to have a negative 1. Let me shorten that a little bit. There we go. Negative 4.48 minus 3. Okay. Which means I get W is equal to 1.48 and W is equal to negative 7.48. So the very first one I highlighted, this would be my exact answer, okay? Which means I didn't have to round any of my decimals. That's exact, precise type of answer, okay? If they told you to simplify to, let's say, 2, 3, 4 decimals, this is how you would do that. You would go about simplifying that radical and then make sure you make one positive, one negative, and then subtract or add whatever is attached to it to get your estimates. I would call these at the bottom estimates because we had to round our square root of 5. I would say if you're asked to just solve, which this notes is just about solving, this is great. But in the next notes, we're going to actually use this method to graph a quadratic equation. And you're going to need these in order to graph your quadratic equation. So it's good to know how to do both. Any questions? Yes?
How did you get to that last part?
How did I get to which part? Sorry?
W equals 1.48.
Yes, so I took what I got here in my answer and I typed square root of 5 in my calculator. And what I got was 2.24. Yes, and then I distributed the 2, so 2 times 2.24, and I got 4.48. But this 4.48, one is positive, and what is negative? That's what that plus minus means. And then I just subtract 3 from both. Okay. Okay, so now we're going to talk about completing the square. And the idea behind the concept completing the square is we need to see if we can find a C value. So remember our quadratics were A, B, and C. Find a C value that if we were to factor the entire thing, we would end up with a perfect square factor. Okay? So for completing the square, in order to find that perfect C value, so we have to find a C value to make a perfect square. In order to do this, we take B, we divide that by 2. So maybe let me write it instead. Take B divided by 2 and square it. And that is going to become our C value. So you could think of this like a formula. If you're asked to complete the square, which you will be asked a lot because I finished test 5. There is lots of completing the square. You will always take that B value, which always is that middle term, the one attached to just a single x. Okay? You will divide it by 2 and then square it, and whatever value you get is your missing C value. So this is the very first step of completing the square. We kind of just broke it down here. So in this very first example, we have x squared plus 12x plus n, and we have to find n such that the polynomial makes a perfect square. Well, we know that this is A, this is B, and this missing value here is C. Well, in order to find that missing value, we're going to take B, so in this case is 12, and I'm going to do, change my color, sorry. I'm going to do 12 divided by 2, and then whatever that value is, I'm going to square it. So 12 divided by 2 is 6, and 6 squared, 36. which means n is equal to 36.
And that's all we're looking for.
This is the first step of a process. So this would be the first step. In this case, that's all we're looking for is that missing value n.
And then you finish, you try to factor it.
And then you would factor it. So since we know our goal is to get a perfect square, what we would do in order to write this factor is that it's always going to be, how can I say, let's call this value right here star, right? It's always going to be x plus star squared. Okay, so in this case, if we were going completely all the way through the steps, this would be x plus 6 squared as our answer. And we were only able to do that because we found a n value that made this a perfect square. But we'll do more of that in the next step. Here we're just practicing that first step. So for the second example, what is our b value? 11. So we would do 11 divided by 2 and then square. Okay, since it's a fraction that can't be reduced, we're just going to leave it as a fraction, which means we just square the numerator and the denominator. So this becomes
22 and 4? Oh,
not quite.
that would be 11 times 11.
121.
121 over
4.
4. Okay, that is our n, that missing value there. Okay, which means if I was to continue on and make this a perfect square factor, this would be x plus
Wait, what'd you ask?
so if we were to make this a perfect factor, we were continue to that next step like we did on the first one. This would become x plus star. And where's the star here in this case?
121 over 4.
11 over 2, because remember our star here was what we were squaring. Okay, so that's why this 6 was there. So technically our star, I'm just giving it a thing to refer to quickly. Our star is that 11 over 2. So this would be x plus 11 over 2 squared if we were continuing all the way. Okay, what is our b value here? Negative 26. So good. Remember, we always take the sign. So if there's a negative in front of that, we're going to continue with that. So we have negative 26 divided by 2 squared. So what's negative 26 divided by 2? Negative 13. And what's negative 13 squared? Positive, right? 'Cause negative times a negative is a positive. That means our n value is 169. So if we were to write this as our perfect factor, would this still be x plus a number?
No,
It'd be x minus 13 because that star value that we're calling it is now negative. Okay, what is our b value here?
Negative 4 over 7.
Negative 4 over 7. Okay, which we are then dividing by 2. Well, dividing by 2 is the same as dividing by 2 over 1, right? And how would we rewrite this if we think back to division of fractions? Multiply by the reciprocal. So this becomes negative 4 over 7 times 1 over 2, okay, which would be negative 4 over 14, which can simplify negative 2 over 7. So that was just the first part, dividing by 2. We had to do some extra steps because it was a fraction. And then we still have to do what? Square it. Okay, and when we square it, we get Is it going to be negative? Positive, right? Because negative and a negative is positive, so it's 4 over 49. That is our n value. Okay, this right here is n. Which means if I was writing this and doing the extra step, this would be x
Plus star, the star is 2 over 7.
negative 2 over 7. So it would be, this is our star. It would be x minus 2 over 7, the whole thing squared.
So is n 4 over 49 or just 49?
4 over 49. Yes, let me box that so it goes with it together.
How do we divide it by 2 or 1? I didn't think that's
So the formula is b divided by 2 squared. So since our b value was this fraction, when we're dividing a fraction, it's easiest just to turn that number into a fraction, right? And then we multiplied by the reciprocal, so reciprocal of 2 over 1 is 1 over 2. Yes, any other questions?
I'm kind of confused about the star. Can you explain it?
That's for following thing, right? That's like the next step.
Yes, that is us going to the next step.
And the next step would be.
What we're doing with the quote-unquote star. This is just the first step.
Oh,
So if
Yes.
you do the x plus star squared, you're just gonna get the n value, right?
So you need the n value to get to that next step, that x plus star squared. And so in this step, so I tried to break it down so it didn't get too confusing. Maybe we should have just went all the way through. But in this step, we are only doing the first step of completing the square. And that first step is to find n. And you'll see it more when we're looking at an actual example. For example, we have this. Okay? So when we're going through the actual steps of completing the square, what we have to know is this extra number that they give us, this 13. This is not the c value or our n value that they mentioned before that we're trying to find. So I would rewrite this as x squared minus 6x, leave a blank, and then plus 13. Because we are trying to find whatever that n value is, just like we did on the first couple problems, that's going to make that a perfect square. So in order to do that, we're still going to take our b value, divide it by 2, and square it. So in this case, what is our b value? 6 or negative 6? Negative 6. So off to the side, I'm just going to write that. That's negative 6 divided by 2 squared. Okay, negative 6 divided by 2 is negative 3. Negative 3 squared, yes, is 9. That 9 is going to go here. Okay, and it's a positive 9, so I'm going to write plus 9. Okay, this is the most important step from here, is if I was to just add 9, is that changing the problem? Yes, I'm moving the problem by adding 9, okay? I don't want to do that. I don't want to change the problem. I just want to rewrite it into completing the square. So if I add 9, I'm going to also have to do what?
Subtract.
Subtract 9, because if I add 9 and I subtract 9, what am I really adding? Nothing, okay? Yes, I'm just going to move this a little closer, and at the end, I'm going to subtract 9. So one more time here, this first part here is what we did in the first couple examples where we found that missing n value. And we did that by doing half of b squared, and that's how we got 9. Well, if I just add 9 to this problem, I'm changing it. I don't want to change the problem. I just want to manipulate the order. So I have to subtract 9 to the very end. So really, I'm not adding anything.
But if you combine like terms, wouldn't it just give you the original equation?
Yes, but we're not combining like terms. We are going to focus only on this part right here.
oh, because now we have the n.
Because now we have n, which means we can convert this to a perfect square. And that's what I was talking about, that x plus star squared. So in this case, what is our quote-unquote star?
Negative 3.
-3. It's whatever's being squared, right? So -3. So this becomes, the thing I boxed becomes x minus 3 squared. Okay, and again, that's where that -3 came from. It's whatever we squared. It's our star value. Okay, so now notice that I simplified that green box. Now I can simplify the like terms on the outside, and I'm not getting the original problem anymore. I'm getting something that looks different, but it's just another way to write this quadratic equation. So I just simplified this part, 13 minus 9. What's 13 minus 9? 4. So I have plus 4 equals 0. Let me see, is this, yes, we're actually solving, okay. So the process we did here for this problem is just the completing the square process. Once we get to this, then we are going to do what we were doing in the very beginning and isolate x, get x by itself, and get an answer. Okay, so what would be my first step from here to get x by itself? Subtract the 4. So I have x minus 3 squared equals -4. Now what?
Get the square root of both sides.
Square root of both sides. So I have x minus 3 is equal to,
I the square root of 4.
okay, yes, I to the square root of 4, and we know the square root of 4 is 2, and I also have to include what in the very beginning? Plus or minus. So this is plus or minus 2i. Okay, then I have to do what to get x by itself? -3 or
Oh, I'm sorry,
add 3, right? Because yes, add 3. So this becomes x is equal to, and remember when we're writing our complex numbers, what comes first, the real or the imaginary?
Real.
The real, and what's real here?
5.
The 3.
Oh, so it's 3 plus or minus 2.
Good, 3 plus or minus 2i, which we could simplify into two answers, which is x equals,
Plus or minus.
so instead of writing plus or minus, we're going to give one a plus and one a minus. So it would be 3
Minus 2i.
minus 2i, and then x equals
Plus
3 plus 2i. Okay. Depending on what they're asking, and by they I mean Alex, right? What they're asking, these would be possible answers, okay? Either they accept it as one and they allow you to do plus or minus, or they don't allow you to do plus or minus, and you have to separate it into two possible answers. So this is what a problem would actually look like, okay? We are going to bring together what we did in the very first couple examples, then in the next couple examples, and then what the entire problem looks like. Any questions?
So our plus 4 is us combining like terms of 13 and not making 95%.
Correct.
So why did we highlight the trinomial there?
Why did I highlight it?
Yes, is that like
I made it, try to make it obvious where this part right here, we're not combining with these like terms.
I understand.
Because if we did that, it would go back to our original problem. We're going to take this, and we did the whole process of completing the square because we want to convert this to a perfect square, which we did with the x minus 3 squared.
So the plus 13 is not our n.
No, it's not Rn. So technically, if you were to graph these two equations, if you were to graph the original one, and if you were to graph the one that we found by completing the square, they're going to be the exact same graph. The reason why we like completing the square is because when we talk on our next notes, we're going to learn how to graph these quadratics, and this is very nice to help us find the vertex of a parabola. And we'll do that next notes. Okay. Okay, so another example, very similar. Before we do anything, we need to make sure this is equal to 0. So what am I going to do to make this equal to 0? Subtract the 3 over. So this is 2m squared plus 10m minus 3 equals 0. Okay. Or if you wanted to do this kind of in one step here, remember we're going to, in the next step, leave a space where? Yes, between the 10m and the minus 3. So I'm just going to go ahead and make this all one step here.
It would be plus 25 minus 3 minus 25.
Not quite. Not quite. Because what is different about this first term versus the other one we did?
That's a 2.
Has a 2 in the front, which means before we continue and we do the formula for completing the square, we got to take out that GCF of 2. So we're going to take out that 2 just from those first 2 terms, right? We're ignoring that minus 3 right
Is that
now.
possible?
Yes, because we're completing the square.
It's just for the first part.
Yes, this is for completing the square. Don't ever just take out GCF from 2 terms if you're just given a quadratic, right?
Right, of course.
We're not doing that. We're doing completing the square. So we're taking out a 2, and so we're left with m squared plus 5m blank, okay? And then that is going to be the end of our parenthesis, subtract 3. And I'm not going to write that equals 0 just yet, so I have space to add or subtract that missing value. Okay, so now what is my b value? 5m, right? That 5. So I'm going to do half of 5 and then square that value. So I'm going to end up with a fraction. So let me do this off to the side here. I have 5 divided by 2 squared. Right? We can't simplify that without getting a decimal. So I'm just going to square the numerator and square the denominator. And so I get what? 25 over 4. Okay. So from here, what I'm going to do is I'm going to add 25 over 4 and then do what to the other side? Minus 25 over 4.
Would it be the same answer if we square root of 25 into n?
Say that one more time.
Could we simplify 25 over 4 and we would get the same answer?
Oh, yes, you could. But when you do that, if you end up with a decimal, let's say like a long repeating decimal, then what you get at the very end is more of an estimate. And the fraction gives us exact values. But I did mess up here because am I just adding 25 over 4? Or am I doing 2 times 25 over 4? Okay, so really I'm adding that. I'm adding, what is this, 50 over 4, which simplifies to 25 over 2. So really, I'm adding 25 over 2. I know it sounds confusing because we're with fractions, but that means I need to subtract 25 over 2. Because remember, my goal is not to change anything. My goal is to technically add 0. Okay? And since I had to take out that GCF here of 2, what happened is when I found this missing n value, I'm really finding a value that is 2 times that. So that's why I have to make sure I first multiply these 2 together before I figure out what I'm adding or subtracting to the very end. Or what's going to happen is I'm going to end up adding or subtracting extra numbers that I didn't mean to do. Okay. So then from here, I know that this is going to be 2 and then m plus
5m?
what is like my star value?
25 over
5 over 2, right? That's the thing that I was squaring. So this part right here.
Oh, do we not bring the square with it? It's just going to be 5 over 2.
Just the 5 over 2. Just the 5 over 2. Okay, and then I square it on the outside. This whole thing is being squared. Then I simplify the outside. So in order to do that, I'm going to have to change that -3 into a fraction, so putting it over 1. And then in order to get a common denominator, what would that common denominator be? 2. So I would multiply the -3 over 1 by 2. So this becomes 6 over 2, or sorry, -6 over 2 because of that negative. And so I have -6 and -25 that are going to add to what? -31. So -31 over 2 equals 0. Okay, so what I found right here is just the part of completing the square. Okay. However, it wants us to also solve. So once we complete the square is when we go back and we try to isolate the variable. So now we're going to get m by itself. Okay. So what would be my first step to get m by itself? Good, so add that over to the other side. So I'm going to add 31 over 2 to the other side. I get 2 times m plus 5 over 2 squared is equal to 31 over 2. Then what? Not quite. Instead of distributing the 2, what can I do instead? Divide the 2. I can divide to get rid of the 2 completely. So if I divide by 2, right, that's the same as dividing by 2 over 1, which means this is technically 31 over 2 times 1 over 2, which becomes 31 over... Yes, I'll write the steps. So this is 31 over 2 times 1 over 2. So 31 over 4. So I have m plus 5 over 2 squared is equal to 31 over 4. Okay, then what?
Square both sides. Perfect.
Square or square root both sides, right? Square root both sides. So I'm left with m plus 5 over 2 equals plus or minus the square root of 31 over...
No,
Square root. Wait, square.
We just plug that in back.
Not quite, not quite. We're trying to get the exact answer first. So I gave the 31 the square root separately from the 4. So I could just write the square root of 4, but we know that is 2.
So the square root of 31 over 2.
And then our last step would be what?
Subtracting 5 over 2.
Subtract 5 over 2. So I have m is equal to plus or minus the square root of 31 over 2 minus 5 over 2. Okay, this would be my exact answer. What if they told you to round to 2 decimal places? How would you type this into the calculator?
Squared equals decimal, and then you would round that and minus 5.
Yes. Okay, so what is the square root of 31? Round to 2 decimal places.
5.56.
Close. 5.57. Yes, 5.57. So we could say, if we split this up, right, because one's positive and one's negative, we would have 5.57 over 2 minus 5 over 2. That's our positive square root of 32 over 2. And then we have negative 5.57 over 2 minus 5 over 2. which is going to give us a decimal, right? So we could even just put it into our calculator, or we can combine it like fractions, and this would be 0.57 over 2, right? 5.57 minus 5. And then this one would be negative 10.57 over 2. And then once you get to this point, I would type it in your calculator, okay? 0.57 divided by 2 gives us m is equal to 0.29 if we're rounding to 2 decimal places. And then the other one, negative 10,
Equal to negative 5.21.
close, not quite. 2, 1, that would give us 42.
5.29.
828.
If we're rounding up, if not, it's 5.28.
2, well, we should round to 2 decimal places, so I would make sure we definitely do that.
So 5.29.
5.29, so negative, right? M is equal to negative 5.29. These would be our exact answers. Or sorry, these are our exact answers. These are our rounded answers, right? Because we rounded in order to get them. That one was a little messy. They're not going to be messy like this on the test. I made sure of it. Okay, so then we have this example here. And notice this is kind of all over the place. It doesn't look like a quadratic at all. So our first step should be, let's make this look like a quadratic. So our very first step is we need to get this equal to 0. So I would add the 30 over and subtract the 6x, which means I have 2x times 2x minus 10 plus 30 minus 6x equals 0. I just moved everything to the left side, so it's equal to 0. But before I can combine like terms, what do I have to do with that 2x in the front? Good, distribute. So I have 4x squared. Okay, there's my quadratic. And then 2x times negative 10 is negative 20x. Bring down the plus 30, bring down the minus 6x equals 0. And then I need to combine like terms before I can start completing the square. So my like terms here are the negative 20x and the negative 6x, which combines to what? Negative 26x. So I have 4x squared minus 26x plus 30 equals 0. Okay. Let's see. This is gonna be not a pretty one. 6.5. That's okay. That's okay. So our first step, right, is to leave space after our negative 26x because we have to complete the square. So this is 4x squared minus 26x, leave a space, plus 30, leave another space, equals 0. Right, because we're going to end up adding and subtracting the same number. Okay, before we continue on though, do we have a number in front of x squared? A 4. We need to try to get rid of that, so we're going to take the GCF of 4 out because we always want that number in front of x squared to be 1. Okay, so I'm going to take the 4 out, and I get x squared, and it's going to be another fraction here. It's minus 13 halves, right? 26 over 4. You can reduce it by dividing by 2, so 13 over 2. Then I have this blank plus 30, another blank equals 0.
So for the negative 26, you would divide by 4, right?
Yes,
I'm getting 6.5.
that is correct, but I don't like using decimals. So 6.5 is the same as 13 over 2. We're going to leave it as a fraction. So yes, you are correct. You are getting 6.5. Okay? So then in order to complete our square, we're going to take our b value. And what's our b value? Negative 13 over 2, right after we took out the 4. So we have negative 13 over 2 divided by 2, so that's 2 over 1. Then we square it. Well, that's the same as doing negative 13 over 2 times
1 over 2.
1 over 2.
So negative 13 over 4.
Good.
Where'd you get the divided by 2 over?
It's part of our formula, b divided by 2. And so instead of dividing by 2, I made it a fraction 2 over 1. And so this gives me negative 13 over 4 squared. And I'm just going to have to square each individually. So what's negative 13 squared? 169. And what's 4 squared? 16. I don't think I can reduce that. I think that's just what it's going to be. 169 over 16. So we're going to...
No, there's 2 negatives.
Correct. So we're going to add 169 over 16. Are we going to subtract that value or a different value?
Something with the 4, right?
So it'd be 4.
4. It'd be 4 times 169 over 16, which, since it's 4 times a fraction that has 16 on the bottom, that's the same as, okay, we can reduce this by dividing by 4, so it becomes 169 over 4. So this is minus 169 over 4. Again, this was 4 times 169 over 16. I made this 4 over 1. Remember, we can always cancel on the diagonal, so I divide this by 4 and get 1, this by 4 and get 4. 1 times 169 is 169. 1 times 4 is 4. Okay, and I forgot my parenthesis right here. And then now that I have this, I know I have that perfect square. So this is going to be 4 times x minus 13 over 4 squared. Okay, and then I have to combine the 30 and the negative 169 over 4 by writing this 30 over 1 and then getting a common denominator of 4. So what am I multiplying 30 by? 4. So what's 30 times 4? 120. So this is 120 over 4. Then I subtract. What's 120 minus 169? Negative 49. So I have minus 49 over 4 equals 0. That is my completing the square. But the problem wants us to solve for x. So from here we get x by itself by doing what first? Not yet. Good. Add the 49 and 4 to the other side. So I have 4 times x minus 13 over 4 squared equals 49 over 4. Now what? Yes, then we're dividing by 4. So we have x minus 13 over 4 squared is equal to 49 over 4 divided by 4 over 1. So I turn it into a fraction, which becomes times 1 over 4, right? So it's 49 over 16. So this is 49 over 16. because we multiply by the reciprocal, right? So we're multiplying by 1 over 4. So 49 times 1 is 49. 4 times 4 is 16.
Maybe it's a fraction because of what?
Made which part into a fraction?
Oh, never mind. We utilize the 4 that we got out at GCF.
Correct.
Multiply it by the 49 and 4. Correct? Or we divide it.
We divided it, yes. Which means we multiply by the reciprocal. Okay, next step.
Oh, your mistakes, man.
Squeeze it in somewhere on the margins. Then you do what?
Get rid of the square.
Okay, by doing the square root. You have to think, we're doing everything we learned in this course in this one problem, right? Like everything we've learned so far. So that's why it feels like a lot. So x minus 13 over 4 is equal to plus or minus the square root of 49 over 16. Notice they're both perfect squares, 49 and 16, which means we no longer have the square root of 49 over 16, but instead 7 over 4. So this is 7 over 4 because the square root of 49 is 7. The square root of 16 is 4. It's actually turning out to be a pretty problem, right? Yeah, because we have two fractions with common denominators now. All that work and it's going to be a pretty answer. So x minus 13 over 4 is equal to plus or minus 7 over 4. Our last step, add the 13 over 4. So x is equal to plus or minus 7 over 4 minus 13 over 4. Okay, that's our exact answer. We would take this and separate it and make one 7 over 4 positive and one 7 over 4 negative. So 7 over 4 minus 13 over 4, negative 7 over 4 minus 13 over 4.
How is it? It should be a positive 13 over 4.
Why? Oh, yeah, you're right, because it's plus. Plus, 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 okay.
Yes. So it is
Now what do we do?
x equals 20 over 4.
X is equal to 20 over 4, which is what?
That is 5.
5. X is equal to 5. What's the next one?
X is equal to, oh no,
Negative 7 plus 13? Or 13 minus 7? Negative 6 over 4, which simplifies to 3 over 2. We got pretty answers here. We got x is equal to 5 and x is equal to 3/2, which is 1.5. We're done. It wasn't too bad. As I'm zooming out more. Okay, yes, of course. Those are our answers. This makes me realize I need to maybe change my notes again. That was a little too much. The test is not like that. But
use whole pages to work with.
how? Oh well, I didn't want to buy paper. This is my campus paper.
Just add like 2 pages and make up a little bit more space down.
Or I see people use sticky notes, right? And they continue on the sticky note and they add it on the sticky note.
Try that, they fall out of
And then you get tape, right? And you tape the sticky note down.
I do this. I get a page.
Oh yeah, then paper.
I use a paper clip.
Yes.
Now I lost the word. It's right here. It's right here.
Whatever you need to do to fit it in that little notes book, because that's the only thing you can use on the test. You can't use extra notes, only what's in the little notebook.
So what I have is not legal. It's not legal.
Technically, no.
It's
Technically. You need to tape it. You need to tape it in, so like if I was to shake it, it's not going to fall out. The sticky notes are fine. But, okay, any questions? You guys should feel accomplished. This is everything we learned in 8 weeks. In one problem.
Can we go step by step real quick? from the
Like
top to the
go, yes, I can, yes. Okay. This is just preparing you for college algebra.
end? Wow.
So,
I'll be
Makes me feel so much better.
you're welcome.
No,
Okay, so our very first step here is I noticed I had this problem that was not a quadratic. So I had to simplify it by making it equal to 0. That was my very first step. So when I made it equal to 0, I added the 30 over, subtracted the 6x, and then distributed the 2x. And then I got this. This was my quadratic equation. So before I could even complete the square, I needed the quadratic equation. Okay? Then I started completing the square. So I started by writing a gap right here, but then I noticed, well, this is not 1, so I had to take out that GCF. When I take out that GCF, I get beautiful fractions, right? So 26 divided by 4 gave us that 13 over 2. And then I took that negative 13 over 2, divided it by 2, and I got negative 13 over 4, and then squared it and got 169 over 16. Okay, that is what I put here. That was my n value.
13 over 2, you squared it by 2, and you individually
Thir-
squared 13 times 13, 4, right?
Yes, yes. But since I added this here, I know I have to subtract a value on this side. But I can't just subtract 169 over 16 because technically this is 4 times 169 over 16.
You divide
So then I multiply 4 over 1, and I did it right here off to the side. 4 over 1 times 169 over 16. I canceled on the diagonals. And I said, okay, I have 4 and 16 here, which means I divide both by 4. And I get 1 over 1 left on the first fraction, and then 169 over 4 on the second fraction. So that's why I subtracted 169 over 4.
Or you could just think, looking at the denominator, it's 16, and you have 4, or instead of 4. You could just find the missing variable, like, right, to equal 4. So, we'll give you,
Not necessarily.
because 16 fits into 4 one time.
But it was a coincidence.
Okay, that's it.
Yeah, it's not standard, it's coincidence.
Okay.
Always think of this. Okay, think, okay, my GCF is a number. Since I'm going to multiply into a fraction, I change it to a fraction. So that's 4 over 1 into a fraction. Times 169 over 16. Okay, so the only reason I was able to say, okay, this bottom part was 4, because I can reduce these numbers on the diagonal. Just like I did when we were doing rational.
So you have to go first, as in like check the fraction by fraction, right? So you can't simplify 4 over 1. You can't simplify 169 over 16.
Correct.
So you go your diagonals.
Correct.
You can simplify 4 over 16.
Correct.
Which gives us 1 over 4.
Correct.
From there we continue.
Yes, so then we're at this part here. Okay, since we found that missing n value, we can rewrite this as a perfect square, and that is that x minus 13 over 4 squared. Okay. And then we combined this 30 and the negative 169 over 4. So we can't just combine it without turning it into a fraction. So that's what all this purple is right here.
Yes. So
Right, did 30 over 1, found the common denominator of 4, and I got 120 over 4 minus 169 over 4.
Wait, why 120 over 4?
Because in order to get a common denominator of 4, I multiplied both by 4. Mm-hmm.
you have to multiply it by 4. Because if you simplify to give us you multiply 4 over 1, so it equals 16, you
No, I
divide
got
by
that.
What happens to what?
What happens to 169 over 16 in the parentheses?
What happened to this here and why is it not here?
No, just what happens to that.
Oh, what happens to it? Well, remember, we find the n value here to turn it into a perfect square.
Oh, that's right, it turns it, gotcha.
Okay, that's why it's gone. We turned it into a perfect square. Technically, if we were to take this, write it twice, and FOIL it, we would get this.
Yes.
Okay. Okay, then we are left with this. This right here is our completing the square form. Okay, so if the question was complete the square, that would be your answer. If the question is solve by completing the square, then what we did everything after, so all of this step here is the solving part. And it was only long because there's fractions, right? We had to get common denominator several times. So once we're here, we added this over to the other side. Okay. We divided by 4, and so we did 49 over 4 divided by 4 over 1, which is the same as saying 49 over 4 times 1 over 4.
We divided by 4?
Yes, from here.
To take the 4 away.
To take the 4 away.
X minus 13 over 4.
Not from the fraction, from this part.
Oh.
I divided by
yeah.
4, yes, to both sides.
Uh-huh.
So that became 49 over 16. And then we took the square root to get rid of the square. And so x minus 13 over 4 plus or minus always. And the square root of 49 is 7. The square root of 16 is 4. So that's how we got 7 over 4. And then from there, we added the 13 over 4. And then we separated it into two possible answers. One where 7 over 4 is positive, and one where 7 over 4 is negative. Yes.
Does it matter if the I goes in front or the back?
Proper notation.
I goes in the back.
So if you're talking about complex number, I goes in the back. If you're talking about just I with a radical, I goes in the front.
Okay.
Okay. One more concept. Okay. Literal equations. We talked about literal equations. I think it was last test where you guys had to, you had big R and little r, and you had to solve for just big R. This is similar. Similar as in we don't just have one variable, we have two. So it says in the following equation, d is equal to 4.9 t squared. Let d be the distance in meters that the object falls and t be seconds, such that t is greater than or equal to 0. Why is that important?
Because it has to be within, we're talking about something.
Yes, we're talking about a real problem, right? And we're talking about seconds. Can you have negative seconds? No, only positive seconds. So it wants us to solve for t, and it says do not rationalize the denominator, which means it's okay to have a radical in our denominator for this case because they told us do not rationalize. So we have d is equal to 4.9 t squared, and we're solving for t. So what would be our first step to get t by itself?
You would square root.
Not yet. Before that. Divide by 4.9. Okay, so we have d over 4.9 is equal to t squared. Now what? Now we take the square root, and when we take the square root, we always have plus and minus. So this means we have t is equal to plus or minus the square root of d over the square root of 4.9. Okay, that is our answer because it says solve for t. Let me zoom back in. Okay, so t is equal to plus or minus the square root of d over the square root of 4.9. Remember, the idea of literal equations is to manipulate the equation to be solved for another variable. And that's what we did. Instead of it being solved for d, it's now being solved for t. Okay. Then we're going to use that equation to answer the last question. It says, how much time would it take for an object to fall 500 meters? So where would we plug in the 500? Into D or T? D, because it's distance. So we have T is equal to plus or minus the square root of 500 over the square root of 4.9. So this is where we would go to our calculator and we would round to 2 decimal places. So we have the 500 square root.
22.36. After that is a
0, good, so 3/6 over, and then we do the square root of 4.9, which is 2.21. And then I'm going to divide them. So 22.36 divided by 2.21. And I get 10.12. Okay? At this moment, I'm deciding to drop the negative. Why?
Because there's no negative distance.
No, not negative distance. Nope. No, wait, say that again.
There's no negative sign.
There's no negative time. Because remember, we're solving for time. We're solving for t. So this is 10.12 what? What's our units? Seconds, right? Because this is time. So would it make sense to say that it would take the object negative 10.12 seconds to fall 500 meters? Can it go back in time? No. So it's only positive. So that's why I dropped the plus or minus, and now I'm left with a positive 10.12 seconds for the object to fall 500 meters.